always like this and C is always like this. That's how the range of subnet masks or the subnet mask of these classes individually. Every range decides something, every range tells you something, and we need to learn how to decode that, because that will help you in any of your major, whether you are a cybersecurity major or networking major. It will help you. So this entire course is um, very important, which is going to create a base for both the majors. Here, if you notice, it is 0, 0, 0. What it indicates? It indicates that I can use these many computers in this network. So if I say my network is this 10, 0, 0, so this is one network. 10, 0, 0, 0 is one network, and the range is all the way from 10 to there can be, this is, I'm only talking about private, but if you look at the public, so I can have a 9, I can have 8, I can have 7, right? And even the A class IP address range is, if I remember it, I don't remember exactly actually. So A class IP address range. So here is the A class IP address range, which starts from 100 all the way to 126. So starting from 1 to 126 is A class. Now 127 does not come in any class. 127.0.0.0 does not come in any class. Why? Because it's a loopback IP address. Remember, 127 range is the loopback IP address, so we do not use in any network. Then you have after 127 is 128. So from 128 to 191, if I remember it correctly, 191 is for B class. 192 to 221 or 222 is C class. You can find it on Google. That's not a big deal. So what I'm trying to say is, how many networks are possible in this range? If you notice, or if you can tell me, then this number in A class, this number is your network, and these numbers are your computers. In A class IP address, this number is representing your network, and these numbers represents your computer. So how many computers are possible in one A class network? Is 255 multiplied by 255 multiplied by 255. Obviously you will leave first and last. You will always leave first and last, but that is the number of computers possible in one network of A class. In one network of A class, you have those many computers. 255 multiplied by 255 multiplied by 255. And how many networks are possible? So we have only 1 to 2, 126. 126 networks are possible. 126 networks are possible for these many computers in each network. But if I go for B class, in B class, the first two bits like this and this, these two bits are for network, and the next two bits Y are for computers. This is for network, this is for computers. In B class. Now you have the range of IP addresses in the B class. 2 IP addresses. So you can, if I ask you again to calculate how many networks you can have, so now you can multiply with two numbers. 255 is the total number of networks possible, and 255 multiplied by 255 is total number of hosts possible in each network. So more network. In B class, you have more network but less number of computers. And in C class, 1, 2, 3 for network and only 1 for host. So in C class, you have a smaller network. You have a smaller network, but you have more number of networks. How many networks you can have? 255 multiplied by 255 multiplied by 255. These many networks are possible in C class, but only 255 hosts in one network. So if I want to create a big size network, I will consider either A or B. If I want to create a smaller size network, I will consider C. But even in C, how many computers are there? 255, let's say, instead of using those some minus 2, 255 computers. But tell me one thing, if I need to use an IP address for my home network, just think about the home network. How many devices you may have in your home? How many devices you possible in your home? Huh? 10, 22, 25, 30. Someday you have a party, big party. Some friends are coming to your place. Let's say 100 Wi-Fi users are there. They all need a user ID. They all need to connect to your Wi-Fi 100. But you are not reaching to 255. So if I use one C class network in my home network, I may end up losing or wasting a lot of IP addresses. I may end up wasting a lot of IP addresses because we don't have any option to use except I can use either C or can I go for B? It's too much. B is too much. I don't want to waste those many IP addresses. So C is the only option left. But one important point which I was saying again and again, that because of this concept of classless addressing, we are no more bound to this configuration. So you just remember that we have some A class, B class, C class. Maybe you remember the range as well, but otherwise you don't need to remember anything more, because now we are using classless inter-domain routing, CIDR notation. And this concept is known as subnetting. What is the concept of subnetting? So if I have 255 computers in a network with the subnet mask of 255.255.255.0, how I can divide this into smaller networks? Using the same subnet mask. And remember, when we have separate networks and subnet masks, smaller subnets, so this will become A network, this will become B network, this will become C network. Within the same number, we created 3 different networks separate from each other with different. This may be your 192.168.1.02.15. This will be 192.168.1.16 to 31. This may be 192.168.1.32 to 47? Yeah, 47. I can create multiple networks within the same range. The range is 255, but I am creating multiple networks, small size network. How many computers? Only 16 minus 2, 16 minus 2, 16 minus 2. These many computers you can use in this network. these many computers you can connect in this network by using this. So you will learn more about it. May not be here, but in other classes. How you can, or you can watch some videos on YouTube, which is easiest way of learning about CIDR.
Illustration that would that be like an example of like a switch, and then it's connected to those different computers, and then its job is to, so like someone from C class wants to send something to A, you know,
Switch doesn't do that.
Oh, it doesn't do that?
Remember, if you want to do a communication between different types of networks, always different types of network, whether it has a different subnet, if it has a different class, because now we are using classless, there is no class. So which is creating a difference in one type of network to other type of, it is only the subnet mask. So only subnet mask which is causing a difference in the network. If one computer is using one subnet and other computer is using a different subnet, these two computers cannot talk to each other by just connecting on a switch. They can only talk when they are connected with the help of a router. Okay, so the router is the only device which connects two different types of networks together. So one router may have connected to 172.131, 192.168, 10.10. So if I have this kind of arrangement, then my computers from one network can talk to the computers on other network. Otherwise not. Okay?
You know how to do the.
So it doesn't matter what is the class of IP address, because we are not using class anymore. So it is always a router. So classless addressing, it is allow your dividing line between the network and host. So now network and host can be of variable size. So number of networks, number of hosts can be increased or decreased based upon the bits adjustment. And this process of dividing your one network into multiple smaller networks is called subnet or subnetting. It's a very interesting exercise. We'll do it sometime. Okay. CIDR is the method of representing your IP addresses in the subnetted environment. And if you remember, we had a /24. So what is this 24? 24 represents that how many bits are used for network and how many bits are used for computer. How many total bits you have? 32. And every octet has 8 plus 8 plus 8 plus 8. So if my notation says /24, that means 3 are used for network, because 8 plus 8 plus 8, 24. How much is less than 8 is used for, the last 8 is used for host. If I say 10.0.0.0/16, what does it mean? What does it mean? Can I have some answer from the backbenchers? Some backbenchers are busy in listening to music or some videos.
Your first two is going to be used for the network.
Yeah.
And then your last two is going to be used for the host.
Last two was used for host. Is everyone getting? Because if I'm getting response from only one person, that it means only one person is learning in this class. Rest of you are not interested in knowing about that. Because some of you I see very busy in completing your assignment, maybe for the other class or maybe for this class. But anyways. If I say /22, if I say /22, What does it mean? Now it's not 8. Now it's not 888. It's somewhere in between. Don't take help from Google right now. You can take help from Google, but not right now. So it is, if you divide it into number of bits, let's say 8 plus 8 plus, how many more you need to get 22? 6 more. And how much left? 10 left. So these many bits are used for network and these bits are used for host. So now you see I can do variable numbering also. It is not necessary to use the whole 255 block. The whole 255 block is not necessary to be used by one network or by one host. I can do a shift or shifting. That that is subnetting, and you will learn more about it. That's how I can increase or decrease the size of my network as per my requirement. What is your requirement? You can decide based on that. Now, based on this number where I said 22, so what is 22? So 22 bits are used for network and remaining 10 bits are used for host. So 2 to the power 10 is the number I can have for host, and 2 to the power 22 networks are possible. That's right.
It makes a difference at the end, like 22, 24.
Yeah. So it is all depends on what is your slash notation. And it's a very, as I said, it's a very interesting concept. Learn more about it from the, after the class, anytime you can watch those videos. So DHCP, what does DHCP stands for? As I said, Dynamic Host Control Protocol. What it does, it dynamically assigns IP addresses to a group of computers. Now those group of computers, first of all, be the member of a domain. So first of all, we create a domain. Every member computer added to this domain. Every member computer added to the domain. Then there is a DHCP server. Now every member computer is making a request to this DHCP server. I am the member of this domain, give me the IP address. So what the DHCP server will do? DHCP server will contact the domain to check the validity of this computer. Is this computer really a part of this domain? Yes, give the IP address. It's not assigned like anyone make a request and get the IP address. If you're not a member, then also you have a policy. For example, you are bringing your computers, your personal laptops to this network, your phones to this network. Those phones and laptops are not the member of domain, but they are still getting IP address. So what we can do is we can define a group of visitors in the DHCP. So these IP addresses need to be assigned to the visitors. Okay, if the request making computer is not the part of domain, then these IP addresses should be assigned to all the visitors. Okay, so it all depends on your policy, because you can control it with the help of various policies. And in Windows, in Linux, we have those DHCP servers. Now servers always runs on server operating system. Remember, we always have two types of operating systems, one for the server and one for the desktops. So desktops cannot run DHCP server. DHCP server can only be run on server operating systems. Server operating system. Anybody knows what is the Microsoft server operating system? (2024, 2022, 2020, 2016). Those are the various servers by Microsoft, Windows servers. And these days Microsoft is having Azure cloud services, so they are running those servers on their Azure cloud services as well. But We need a server operating system. And DHCP is what? DHCP is it's a service. It's a server. It's a server application running as a service. Okay? All right. 1 minute, please. So DHCP is need to be, so this is one example is given for DHCP on running on Linux computer. So there are a lot of things. DHCP is not just as we are talking about it in 1 minute. It's a big topic. For those who are studying it in details in their major, you will get to know about DHCP in more. So you can set the rules on DHCP. Who should be included, who should not be included, what kind of operating system should not get the IP address. Let's say you don't allow Linux computers, or you don't allow a particular version of Linux in your network, you don't allow Android phones on your network. So those kind of inclusions or exclusions you can apply in your DHCP. You can also set the lease period, how long the lease should be allocated. Address translation. Now these are the activities where the address is translated when you are communicating over the network. Means when you are sending any message on the network, then depending on your network is what is the destination of your message, some translation takes place of on your IP address. If your message is only for your computer, from one application to other application, so how does it work? So your application A and this is your application B. Now how this application can send a message to the other application that runs, so every application has a particular port number. So this runs on port X, this runs on port Y. So when you are sending a message from application A to application B, so you are basically telling your message that go to port number Y for application B. Go to port number Y for application B. So message leaves your application. This is your computer. Message leaves your application but does not leave your computer. It does not leave your computer and search for port Y. Within your computer it is searching for port Y and then it goes to that particular application. So within the computer, your application, your communication takes place on port to port because you don't need a network. But if it is going outside of your computer, if it is going outside of your computer, then a lot of translation takes place. And that translation is given here. So first is called network address translation, is a process where a gateway device substitutes a private IP address with its own public address. Because I hope you know that we have two types of IP addresses, public and private. Public IP addresses, so do we have public IP address on all these computers? No, we don't have public IP address on these computers. We have only private IP address on these computers. So when I want to go for google.com, so google.com, will the google.com see my IP address? Answer is no. Your google.com will never see your IP address. So let's talk about how this starts. So you are here on the browser. It is what it is? Application. You are saying google.com on your browser. So first of all, DNS comes into the picture, and DNS will translate google.com into what? Somebody says from here, IP address. I know you know, but I want to hear others. So DNS will convert the google.com into an IP address. Now from this IP address, so this is my destination. And what is my origination? Origination or originating application is this browser. So there a message is created, a message block is created. In this message block, lot of information is added. What is the request? IP address. Which application is making a request? Which tab on that application? If you have multiple tabs, which tab is? So this is an application ID. There is a tab. If the tab is there, then tab ID is also there. So message block. And then it reaches to the transport layer. Or instead of giving about each and every layer, let me just give you an idea. So what else it is adding? What other information it is adding? So it is adding the IP address of the computer. It is adding MAC address of the computer. It is adding port number of the application, on which port number this application is running. And then it tries to establish a communication with your gateway. Gateway, because gateway is the point from where your request will go out on internet.
These computers have a gateway, but they don't have a public IP.
No, yeah, they don't. They have gateway, but no public IP address. So when it reaches, this request reaches at the gateway. This IP address here, this IP address is replaced by the gateway IP address. The IP address which belongs to this computer, that is a private IP address, is replaced by gateway IP address at this point. And this gateway is assigned a request ID. It generates a kind of request ID and assign a request ID to this request. A request ID. Now this information is with the gateway. This request ID is with the gateway, and now the message goes, because the public IP address is with the gateway. Now gateway has two types of IP address again. One is private IP address, another one is public IP address. Private IP address to communicate all the internal network, public IP address to communicate with rest of the internet. So it replaces the private IP address with the public IP address, assign a request ID, keep that request here, and send the message to the internet. From the internet, it receives the response. Response contains the gateway IP address, and also contains the request ID. Why gateway IP address? Because otherwise it won't reach here. If it does not contain the gateway IP address, then it will not reach to this gateway, because that is the identification for the gateway. So this response is coming back to the gateway because of the IP address. Now this message contains the request ID. So gateway has the information about request ID. Now gateway identifies who made this request. So whatever the response was there, it attaches all that information it has in the request ID. It attaches all that information and send it to the internal network. Now internal network, what the request ID contains? IP address of the destination, MAC address of the destination, port number of the application, tab ID, application ID. All that information is the part of that request ID. Will it not reach to the right destination? Definitely it will reach at the right destination, to the right computer, right application, right tab. It won't miss, because each and every point it is passing, it's like a it's like a gate. Multiple gates are there when you are entering in a building. Multiple gates are there, and every gate you are getting a stamp. You are getting a stamp. And when you are coming back, the stamp was checked. Were you stamped when you going in? Were you stamped when you going in? So it will reach at the right spot. That is obviously, I'm not going into that. Okay. Now what you are talking about is related to authentication. Right? So what he is talking about actually in authentication, what do you authentication? When you do authentication, what do you do generally? Tell me.
You gotta check one thing as another thing, probably.
So when you are supposed to authenticate yourself, what you do generally on internet, let's say.
Like an ID,
Provide the user ID and password. Keep it simple. You provide the user ID and password. What happens with the user ID and password?
check it against some kind of data.
It goes to one server, check the database, and what it does, what the database will do, it issues a token to your computer, to your application. It issues a token. Now you use that token and keep on working. It keeps your session active. Just imagine you are working on your computer at home. You logged into Gwinnett Tech Blackboard. What you do? Okta. Okta is basically like even after providing user ID password, you are using Okta. It is called multi-factor authentication, MFA. But again, you are getting a token, and token has a time limit. If you, let's say, you leave your system for a while and you come back, you may see that you are logged out. Why? Why? Because the token has a life. If your session is inactive for a certain period of time, it will expire. Or if you log out and come back next day or after a few hours, you need a new token again. So there are two types of authentication we follow in industry. One is called two-way authentication, means only one server is involved in verifying your information, and there is another way is called three-way authentication, whereas another server is involved to verify your IDs or it is authenticating your devices or your account. So port address translation is assigning the port, is the process of assigning a TCP port number to each ongoing session between local host and internet host.
Is it a security question? Is that simple, like three-way
What?
authentication?
Yeah, so it's a kind of a security question. There are types of authentication mechanism, so two-way and three-way. So two variations of NAT, one is called SNAT, which is source network address translation, and another one is called DNAT or dynamic network address translation. So if it is source NAT, the gateway assigns the public IP address to a host each time it accesses the internet. DNAT host as outside the network address a computer inside the network by a predefined IP addresses. So basically, when you are let's say your computer is communicating over the internet, so your gateway will assign a public IP address to your computer every time you are trying to access internet. Generally, we do not use SNAT, we use DNAT, where hosts outside the network address a computer inside the network by a predefined. So basically it is having a predefined IP address to all the computers in the network, and based on that, every request which is going out of the gateway to the internet, it assigns that IP address to that request so that the request reaches back to the same gateway. And whenever it goes back after this, once it reaches to the gateway and going inside the network, it always uses the local IP address which is assigned or which is provided to the host computer. That is your port address translation. So port address translation is basically communicating hiding the port used by the internal computers and only exposing the port of this router. Now, by doing that, we are basically creating a security boundary also. If you look at this diagram, every computer has an IP address. Every computer is using one particular port for communication, but this gateway device, which is a router, a kind of a router, is hiding their IP addresses, is hiding their port numbers as well, which port number they are communicating, only exposing what is supposed to be exposed. So this point, only internet can see only this point. Internet cannot reach to any of these computers in this network. That is the role of router. This is the role of gateway. And also we can add little bit more security to this by adding a firewall. And firewall sits here. Firewall sits here. So all the network traffic will hit the firewall first and then only it goes further. So what the firewall can do? Firewall can block certain IP addresses. Firewall can block certain port. Means if your request is coming for a certain number of, for certain type of port, the firewall will block that access. So only which are allowed will go into the network. That is IP address. What is this? This is the IPv6 address. So it is explaining everything about the IPv6 address. In this, you have a 128, as we discussed about 128. This is an example of complete IPv6. Now, in place of 00, where everything is 0, you can remove it and just replace it with the colon signs. So instead of 00, I can just put 2 colon signs here. Instead of 00, I can put just 2 colon signs here. So only the addresses, and even we can expunge these leading zeros. So this at this part here will only be read as D3. This part here will only be read as B80 or B80. So you can remove those. So each 4 character blocks is a 16-bit block in hexadecimal. Leading zeros in a 4 character blocks can be eliminated, right, and can be replaced by the colon sign only. So for example here 2001 B80, so you can remove this with the 2 colon signs like this one. Yeah. Right, so this is another replacement of 00. So either B80 only D3, because it removes all the leading zeros and all the zeros replaced with the colon sign only. Okay, you can reduce it further. It is not reduced here because you see this one is having all the zeros on it. So you can have this one and this one combined where all the zeros are replaced. These are some other terms which we are using in IPv6 such as a link, and these all are almost same as your IPv4 network also, IPv4 addressing also. Like a link, sometimes called local link, neighbors, other computers in the same link or same network. Interface ID is the last 64 bits or 4 blocks of an IPv6 address that identifies the interface. So it is like a MAC address. So the first four blocks, if you look at this, first four blocks are for interface and last 4 blocks are for computer. Tunneling. Now what is tunneling? Tunneling is basically creating a separate network within the network. A separate network within the network. So it is a method used by IPv6 to transport. So if you have this network, let's say this is your network wire, a network cable. So tunnel is like you have created a small path within it. So sometimes we call it dedicated connection between the source and the destination. Then you have NAT64, which is your network address translation for IPv6. and it is supporting version 4 and version 6 both. Now these are all good to read kind of things. Unicast address, global address, local link address, loopback address, multicast address, anycast address. So when you read this chapter, when you go through this chapter again, then you can. Are you also facing this issue of not viewing the pictures? There's something wrong. It's not showing pictures. IPv6 auto configuration. So in case you are using automatic assignment of IPv6 addresses. Let's do this knowledge check activity. Which of the following IPv4 addresses is a public IP address or addresses? Sorry? Public. Someone saying B. Someone saying A. Someone says D. Anyone remembers that particular slide? Here. These are for private networks. All the way from 10.0.0 to 10.255 to 55.255 means everything which starts from 10. Everything which starts from 10 is private. Everything which is in the range of 172.16 to 172.31 is private. Anything is in the range of 192.168.0 to 255 is private. Now look at these IP addresses again. Anything which starts from 10, private. Anything which is in the range of 172.116 to 31, private. So what about B? Anything which is in the range of 192.168, private. So what is left? D is left. Okay. But if I have, let's say I have an IP address here 192.172.8. 172.8. So 8 is not in 16 to 31. So that will be public. Okay, now for the security reasons or for any application running, we always use two things. One is called port, another one is called socket. If you are going to do this cyber security or even the networking major, you must remember, sometimes those who are working on cyber security or networking, they always keep the port list in front of their screen or somewhere so that they can see it very easily. Which service is using what port? Which service is using what port? Now, in general, port and service are always fixed. Means this service will use this port number. HTTP 80, HTTPS 443, Telnet 13 or 14, SMTP 21, FTP 23, and so on. But there are provisions through which we can change those port numbers. Okay. So if you are working for some organization, then you must know that in this company or in this organization network, which service is using what port number. Huh? In the example, for example, here it says that 10.43.3.87:23. So 23 is the port number. 23 is the port number. So port number is assigned to a process that can receive data. So for example, why we need a port number? It's very obvious. In one computer, there are multiple services which are trying to communicate on the same network. Now this computer has one IP address only, 192.168 blah blah. and three services are using the same network, how they will get the different data? So it's all the port number. So 80 is here, 443 is here, and 23 is here. So the network communication will take place based on the port number, and then it reaches to that port service. Okay, so if this data is for 80 or for 23, so accordingly it will be delivered to that application. And the socket, now socket is not physical thing, port is also not physical thing, it's all logical. Remember this thing. It's not visible. You can't say, okay, where is my port? Can I see the port? You may say that RJ45 connected is a port, but it's a physical port. These ports I'm talking about, which has a number 80, 43, 23 or any other, these all are logical ports. You can't see them by eyes, but you can see them on your computer by using some commands. On commands, it can display. You can display what port numbers are. So socket is basically, again, it is a logical thing, consists of host IP address and the port number of an application running on the host. So two information together, two information means socket contains the information about the IP address and the port number. In programming, those who are interested in going towards programming, socket is the way to use or to establish the communication through programs. So socket is, it's a software component. So software applications can address a socket, can talk to or can use socket for network communication.
It's your IP address and the
Port number of the service.
Yeah.
So what does it mean? If I have three services here, so how many sockets would be here? Three. Every port number will create a separate socket which includes the IP address and the port number. IP address, port number, IP address, port number. By capturing or by using this socket, you can actually use or write a program to communicate over the network with the help of any programming language such as Java or Python. Now these are the port types. So we have well-known ports, registered ports, and dynamic and private ports. Well-known port means the ports which are assigned to certain services, or we are calling them a kind of fixed ports and the services. Registered ports are registered in the operating system, can be used by any service. If you are creating a service in your computer using some program, some application, you can use any of those registered port. And dynamic and private ports, which you can use again for your services, but they are not registered. You may need to register them before you can use it in your application. So only 0 to 1023 or 1023 are the port which are known or used by standard services in the computers. Now you have this domain name and DNS again, which is, we have discussed a little bit about all this in the previous discussion today. Now ICANN, which is a body which allocates the domain names to different websites or services, so such as all these, right, .com or any country specific domain name, all that is. Now namespace, name servers, resolvers, so these are the terms used by the DNS. I would suggest you to watch Professor Mercer's video on DNS. That will give you a more clear picture how all the things are working in the domain name. Now in the DNS, actually, in DNS we have lot of entries. DNS is just like a database. It's not. It's a service, but it is a database also. So what the database contains Database contains all the information about your websites, about your FQDNs. So your FQDN is translated into a IP address and vice versa. We have two types of translations in DNS. One is called forward translation, another one is called reverse translation. Forward translation means name to IP address. Name is resolved into IP address. Reverse translation, IP addresses are resolved to names. So all this information is contained in the database of DNS, and every entry, or there are various record types in the DNS. So these are the various record types given here, like namespaces or name servers or resolvers. So if you watch that video, you will get more ideas. So again, you may try it today, watch it today, get the knowledge today, or you may do it later when you are in need of more information on DNS. So namespace databases are basically the databases which are containing all the information about the names. Now when I say names means like computer names, they are user names, right? So it is going to authenticate your identity, or going to check your identity if you exist in this network. These are the various name servers such as DNS or primary DNS, secondary DNS, caching DNS, forwarding DNS, or otherwise we can call it a role of DNS. The picture's missing. I need to figure out why the pictures are missing. These are the different types of records, what I was saying, the record types: SOA, A record, AA record, CNAME record, PTR record. So these are the different types of records: mode, name server record, mail exchanger record, and text records. So these are the different types of records you have in the DNS, which contains different kinds of information. Some of the troubleshooting tools which you can use in your network: ping. Ping is the tool which you can use to check if the particular network or particular IP address exists and active in the network. For example, 127 will always give you green signal. But if I, let's say, try 10.182.92, so if I'm not getting any reply from this IP address, means the IP address is not active in the network. If let's say a known IP address is not responding, let's say I know what is the IP address of Nigel's computer, so I say ping to his computer, but it's not responding. That means there is something wrong in his computer's network. Or if someone's network is not working, then what is the first step you take? You check the IP, if the IP address is responding on that particular computer. That is the first thing or first step you do. Right? If the ping is not responding, that means the network is not working. It may be other reasons, like it may be Wi-Fi is not connected, it may be physical network is not connected. If the computer is on Wi-Fi, you can check if the Wi-Fi is off. If the off is from the computer or off is on the terminal. So these are the various steps you follow when you are working on any troubleshooting. So it's like a tree. It's like a tree. You have a problem. Then you set up a scenario. Scenario 1, it has two possibilities: 1.1, 1.2. Then it has three possibilities. It has two possibilities. You are ruling out those possibilities one by one and working on one of the possibility here, and you find the final or ultimate issue with the computer or with the system, and then you work on the solution of that problem. Then you start working on the solution, if it is that. Sometimes you may find the problem in the second step, sometimes you find it at the third step, sometimes you find it at the first step, depending on what kind of problem is that. And remember, this ping is not a solution which works everywhere, because in some cases ping is not allowed. In big corporate networks, ping is not allowed. So you may need to use some other methods which will be provided there, and you will use only those methods. Now, in order to do the IPv6 ping, you have ping 6, right? So you can go through these troubleshootings. I will try to discuss these troubleshooting tools next week again, when we meet, so that we can review all the troubleshooting steps. Now, can you answer this? It's B, ICMP. Okay? It was there on that slide if anybody noticed here. Internet Control Message Protocol. Alright, so try to do the lab of this lesson. Let me see what are the labs associated. So we talked about, you need to watch this. It's a very useful video. Build a MAC address table in Packet Tracer. So if you are using Packet Tracer, which is useful for any one of you in the doing major of cybersecurity or networking, because Packet Tracer is one application which helps you in building your own network within the computer. So by adding multiple switches, routers, computers, you can build your own practice network in your computer, and you can do practice there. And assignments, you have one lab implementing IPv4 network services. Manage a DNS cache is optional. Addressing, this is a quiz. Scenario based quiz. So kind of we have just one lab here in this lesson. IPv4 network addressing. And as I said in the beginning, if you are facing problems in doing the labs, right, then talk to me outside the class hours, because that problem is your problem. If it is, let's say, problem of the entire class, your lab is not working, then we will be doing it in the class. We can discuss it in the class. But if it is a lab is not working, one particular person is having technical difficulty in understanding what this lab is all about.
That'd be me.
So you should talk to me outside the class. Reserve a time with me that I would like to sit with you, and try to avoid Wednesday, because Wednesday is quite busy for me. I have another class in the next 1 hour. So try to come on other days, like you can use Monday or you can use Thursday. Okay? Or if you want to solve this today, then we have some tutors. I'll let you know if any tutor is available today to help you.
What's on Monday and Thursday?
Huh?
What's on Monday and Thursday?
What's on Monday and Thursday?
Yeah.
Will be available on Monday and Thursday.
I think he said what time.
What time?
Yeah.
Oh, that you need to check with me. Monday, anytime you can come. Anytime on Monday means 9 to 5. Thursday, I have class until 11:30. After that.
What, AM or PM? 11:30.
PM? No. You don't do classes on PM.
No, sir.
8:30 PM is the class ending, and no class after 8:30 PM. Okay?
Understood, sir.
All right. Fatima, you had some question, yeah? Come here.